Good day everyone, it's me Arvind catching you on another Math Tutor Edu's math video. Okay, in this video I'm going to discuss some of the derivatives of trigonometric functions, which is tangent, cotangent, secant and cosecant, as this video is the continuation of the previous part of the video. Okay, why I'm making this video specifically because I want to show you the derivation of the particular trigonometric functions, guys, because sine and cosine is considered to be a straightforward trigonometric functions, whereas tangent, cotangent, secant and cosecant, they are slightly complex. Okay, so without further ado, let us begin our derivation now, starting with tangent. Okay, so from here let us begin our derivation with tangent. Okay, let me just write here tangent x. Okay, so this tangent x, so we're going to write it as sine x, okay, divide with cos x. Okay, sine x divide with cos x, you can be able to get the tangent x. So we are literally simplifying the equations. Okay, so from here y is equal to sine x over cos x. Okay, so for the next step, what you're going to do is we're going to perform the derivation, or we can call it as differentiation. So what we're going to do is we're going to apply the quotient rule. Okay, so the quotient rule follows like this. Okay, the numerator we set it as u, whereas the denominator we set it as letter v. Okay, so from here y prime, okay, will be equals to v u prime minus u v prime, okay, divide with v square. Okay, so let me underline the fraction, and it's better for me to box this formula. Okay, let us perform the derivation. Okay, so from here y prime is equals to, okay, v in this case is cos x, okay, times with u prime. Okay, when we differentiate sine, you should get cos, so in this case here will be cos x, okay, minus with u. Okay, in this case u is sine x. Okay, just write here sine x. Okay, times with v prime. Okay, v over here is cos x, so when we differentiate cos x, you should get is negative sine x. So from here negative sine x. Okay, and then you divide with v square. Okay, in this case v is cos x, so v square is cos x square. So from here it will be cos, okay, let me write it properly, cos x in a bracket square. Okay, so from here let us perform the expansion. So from here y prime is equals to, okay, cos x times with cos x will be cos square x. Okay, negative sine x times with negative sine x, you get positive sine square x. Okay, and then you divide with cos square x. Okay, so from here, so this cos square x and sine square x, we can actually simplify them using the basic trigonometric identity. Okay, if you forget it, let me recall it. So from here, basic trigonometric identities were sine square x plus cos square x is actually equals to 1. Okay, so from here, this is the basic trigonometric identities. So we're going to replace 1 over here. This cos square x and sine square, we're going to replace it as 1. Okay, so from here y prime will be equals to 1 over cos square x. Okay, so from here we are very close to our final answer. So since 1 over cos x is equals to secant x, so from here you have 1 over cos square x. So 1 over cos square x will be equals to secant square x. Okay, so this is your answer. Okay, so from here now you know the reason why when you differentiate tangent x, you immediately get secant square x. So this is the derivation, guys. Okay, we derive our equation all the way till we get this final step. Okay, so let me underline the solution. Okay, so from here let us proceed to the next one, which is cotangent x. Okay, cotangent x is slightly similar with tangent x. Okay, so from here cotangent x, okay, cotangent x, so we can write it as 1 over tangent x. Okay, so 1 over tangent x, since tangent x is sine x over cos x, so from here you can write your equation as 1 over sine x over cos x. Okay, so let me do it step by step. Okay, so from here you get your y is equals to cos x over sine x. Okay, so the divide become multiplication, so the fraction will be inverted, so that's how you get cos x over sine x. Okay, so from here, once all done, okay, now we can proceed to perform the derivation, guys. Okay, so from here, similar like the previous working, so we're going to use the quotient rule. Okay, so we're going to set this as u, set this as v. Okay, same, y prime is equals to vu prime minus uv prime divided with v square. Okay, so this is the quotient rule. Okay, let me box this. Okay, so from here let us perform the working now. So from here y is equals to, okay, v in this case is sine x, so let me just write here sine x. Okay, u prime in this case, okay, is the derivation of cos x, so you differentiate cos x, you get is negative sine x. Okay, and then minus with, okay, u, okay, in this case is cos x. Okay, just write here cos x. Okay, and then v prime. Okay, v prime, when you differentiate sine x, you should get cos x. Okay, so and then you divide with v squared. So in this case, your v squared is sine x squared. Sine x squared. Okay, so from here let us continue our working. Okay, so from here y prime is equals to negative sine square x minus cos square x. Okay, and divide with sine square x. Okay, so here what we're going to do is we're going to factor out the sign, the negative sign. Okay, so from here at the numerator we're going to factor out the negative, so we only left with sine square x plus with cos square x. Okay, and then divide with sine square x. Okay, since in the part A I have discussed about basic trigonometric identities, okay, the same thing we're going to apply over here. Okay, let me just copy paste the formula. Okay, so from here y prime is equals to negative 1 over sine square x. Okay, so from here we are very close to our final step. Okay, since 1 over sine x, we can write it as cosecant x. Okay, so from here Okay, let's say for example 1 over sine x is cosecant x, so 1 over sine square x will be cosecant square x. Since here you have the negative, so here will be have the negative as well. Okay, so that's how you get your y prime is equals to negative cosecant square x. Okay, so we have done the derivation of tangent and cotangent. Okay, so from here let us proceed to the next one, which is secant. Okay, part C, secant x. Okay, so for secant x, so you're going to simplify our equation as y equals to 1 over cos x, 1 over cos x. Okay, so this cos x, the fraction form, 1 over cos x in the fraction form, you're going to change it into the index form, where it will become y is equals to cos x to the power of negative 1. Okay, so from here let us perform the differentiation. Okay, so from here y prime will be equals to, okay, negative 1. Okay, you bring it to the front, you times in front, so from here you get negative 1. Okay, cos x, okay, the power you minus by 1, so you get here minus 2. Okay, actually you can just leave it as negative, but I decided to write the negative 1 here for understanding purpose. Okay, and then you need to times with the differentiation inside the bracket here, so differentiate the cos x, you get here negative sine x. Okay, so from here y prime will be equals to, okay, negative 1 times with negative sine x, you get is sine x. Okay, and then times with cos x to the power of negative 2. Okay, so let us change it back into the fraction form. So from here sine x will be divided with cos square x. Okay, you can write it in this form. Okay, for the next step, what I'm going to do is I'm going to factor out the cos x. Okay, so from here y prime will be equals to, okay, 1 over cos x. Okay, and then times with sine x divided with cos x. Okay, so we are very close to our final step. Okay, 1 over cos x is also known as secant x. Secant x. Sin x over cos x is also known as tangent x. Okay, so this is the reason why when you differentiate secant x, you get secant x tangent x as your answer. I mean, that's why we literally use this formula, guys. Okay, so we still have one more left, trigonometric function, which is cosecant. Okay, let us discuss that as well. Okay, part D, cosecant x. Okay, for the students, okay, let me just remind you that certain books, they will write your cosecant as cosecx. Okay, this is also correct, but there's some of them they just prefer to write cscx. Okay, this is also correct. Okay, either way it is up to you guys, for the students, but I've decided to write in this way, okay, for the convenience. Okay, cscx cosecant. Okay, so this cosecant, so I'm going to break it down. Okay, it will be equals to 1 over sine x. Similar step as the part C. So this sine x, okay, which in the fraction form, 1 over sine x, which in the fraction form, so you're going to change it into the index form. So from here y is equals to sine x to the power of negative 1. Okay, so from here the negative 1 you're going to times in front. Okay, so we're going to perform the differentiation. So from here y prime is equals to negative 1. Okay, in a bracket sine x to the power of negative 2. Okay, differentiate the differentiation inside bracket, okay, the trigonometric function inside bracket. So from here you get cos x. Okay, so from here negative 1 times it cos x times you get negative cos x. So from here y prime will be negative cos x. So from here you get sine x to the power of negative 2. Okay, so from here what you're going to do is we're going to change back into the fraction form. Okay, so from here negative cos x, okay, and then divide with sine square x. Okay, so far so good. I hope you guys can able to understand my working till now. Okay, so from here similar step as the part C. So what I'm going to do is I'm going to factor out the sine x. So from here 1 over sine x. Okay, let me factor this out. Okay, so from here you are left with negative cos x over sine x. Okay, so from here y prime will be equals to, okay, this 1 over sine x we can write it as cosecant x. Okay, and then times with negative cos x over sine x. So this expression is actually, we can write it as negative cotangent x. Okay, so from here we can actually rearrange this equation, okay, such that, so this negative we can put it at the front. So this negative, since everything is actually a product, is a multiplication, so this negative we can actually place it over here, guys, at the front. Okay, so from here y prime we can also write it as negative cosecant x cotangent x. Okay, so this is how the way it is. So the negative, it's basically like cosecant x times with cotangent x times with negative 1. Okay, the negative 1 you can just place it in front over here, guys. Okay, there is no right or wrong. Okay, but the reason why you're writing this, we are trying to prove that when we try to derive a certain trigonometric function, we follow exactly the formula. Okay, so from here we can able to conclude that when we have a cosecant x, so when we derive it, so we get the y prime is equal to negative cosecant x cotangent x. Okay, so from here let me underline this. Okay, so that is all. So let me scroll this up. Okay, if you like this video, make sure that you give a thumbs up. If you haven't subscribed to the channel, make sure that you subscribe to the channel and hit the bell icon for more upcoming math content in the future, and make sure that you share this video to your friends. Thank you everyone for your support, and I'll see you in the next video.